Okay, exponential functions are inverses of logarithmic functions, and logarithmics are inverses of exponentials. So when you see this, log b of y, what that means is this. B is the base, that's a number, and y is the number that you're putting into that. I'm teaching that law. That's somebody in Florida called me. Who is that? I don't know. I've already told them what to leave me alone. I'm really going. And I'm still recording. Right. All right, so to do problem 1A, here's what you do. You drop the logarithm. Okay, you drop the logarithm, you trade places. Okay, 2 to the third power equals 8. Okay, and that is a true statement. Okay, let's go to B now. Okay, what's the first thing going to do? Drop the logarithm. What's the second thing going to do? Switch the places. Good job. Okay, so you're going to write down what? 4 to the 0 equals 1. Now, is that a true statement? Is anything to the 0 power equal to 1? Yes, it is. Okay, that's what you were taught in this class. Okay, so 4 to the 0 does equal 1. That's a true statement. Okay, let's go to C. Same thing. What's the first step? Drop the log. What's the next thing? Switch places, right? Okay, so you're going to write down 12 to the first power equals 12. That's not a true statement. Is 12 to the first power equal to 12? Yes, it is. That's a true statement. Okay. Okay, look at D. What's the first step? Drop the log. What's the next step? Switch the places, right? Okay. All right. So you're going to write down what? 1/4 to the -1 power equals 4. Okay, now is that, okay, so now here's this. When it's a negative power, right, which you can't have, what do you do with the 1/4? You take the reciprocal of it. So you have 4 equals 4. So is that a good statement? That's a good statement. There you go. That's the first example you got to do. Okay, so here's example 2A. Okay, you're evaluating this. All right, so here we go. Step number 1. Set this equal to x. Okay, now step number 2. Drop the log, make the switch. What are you going to write down? 4 to the x power equals how much? Okay, now you tell me, what does x have to be? 4 to what power is 64? 4 to what power is 64? 3, so it's 3. X equals 3. Right, 4 times 4 times 4 is 64. There you go, the answer's 3. Okay, let's go to the next one. What's the first thing you do? Set equal to x, okay. Okay, then what do? Drop the log, then what do? Switch the places, right? You're going to write down what? 5 to the x power equals to, okay, 0.2 or 0.2. Very good. Okay, now you tell me how much is x? -1 is correct, and x will be -1. Very good, that's right. And once again, these are all things you know how to solve now. Okay, you've had those lessons, it's just seeing how to do it with logarithms. Okay? All right, let's go to C. Okay, so C we got, okay, this is set equal to x, right? Drop the log, make the switch, right? Okay, you're going to write down what? 1/5 to the x power equals 125. Okay, now you tell me how much does x have to be for 1/5 equals? Say again? -3. Very good. X is -3. That's right. X would have to equal -3. There you go. There's the answer. Good job. You got it. Okay, let's go to the last one. Last one's kind of one that tricks some people. All right, so you're going to set this equal to x. It's a feed. You're going to drop the log, make the switch, okay, and you get what? 36 to the x power equals 6. Okay, now you tell me what does x equal? Okay, which is what? 1/2, which is 1/2, is right. Okay, x would equal 1/2. And you guys know that because what? When you have a fractional exponent, it means you're taking a root, right? So 36 to the 1/2, what's the other way you say that number? The square root of 36, right. That's the square root of 36 is 6, is what you're saying. That's right. The next is 1 half. Okay. All right, there are two kinds of logarithms that we're going to be using. Okay, now one is what is called a common logarithm. All right, now here's the thing. A common logarithm is a logarithm that always has base 10. Okay, so log base 10 of x, okay, is called a common logarithm. Now here comes the thing. There are two ways to write this. One is to write it with base 10, but then there you can also write it without that base. You can just write down log x. So when you see this, log x, it means the log that has base 10. And it's done both ways, as you'll find out as you go through these lessons. So these both mean the same thing. So when you see this, right, log 10 of 7, it's the same thing as saying this, log of 7. They mean exactly the same thing. One has the 10 for the base, one doesn't, but it's understood to be base 10. Okay, now look at the other one. The other one is a natural log, okay? So natural log is taking log base e of x, right? Now what does that equal? That equals this thing, which you've seen this now already on the calculator. ln, which means natural log of x. Okay? All right, so these problems you have to do are super simple. Okay? All right, all you're going to do is this. You're going to go to your calculator, put log in the calculator, and hit the number 8 in the calculator. Close the parentheses. And what we normally do is round it to the 4th decimal place. So go type in log, okay? Okay, and then 8, close the parentheses, press equals, all right, now round it to the 4th decimal place. What are you going to do? Okay, 0.9, 0, 3, 1 is correct, and that's what you write there is the answer. It's that simple. And log problems are very calculator driven, okay? There's lots and lots of calculator use. Okay, let's go to the other one now. Natural log of 0.3. So you're going to hit ln, right? And punch in 0.3 and close the parentheses. Okay, what's the answer to that? And round to the 4th decimal place. So 0.204, right? And even right there, we could write down 40. Okay, those are both good answers. All right, so here we go. All right, so this is a real easy word problem, right? Okay, so you see that the tornado travels 220, so we're going to substitute 220 in for D, right? Okay, all right, so you're going to do this. You're going to write down S equals 93 log, and then for D, you're going to put in 220, right? And then close parentheses and plus 65, right? Okay, so go put that into the calculator. It's that simple. Just chuck it into the calculator. Okay, now S represents what? The speed of the tornado, right? Which normally you'll hear that only used like they had a tornado, it was clocked at so many miles per hour. So round this to the whole number this time. So what would you write down as the answer? 283, right? And so S turns out on the calculator speed 283 miles per hour. That's it. That's the problem. It's that simple.